In today's lesson, we're going to learn how to add and subtract polynomials. The difference between adding and subtraction is these following steps: that for adding, we just combine like terms. For subtracting, we have to distribute the subtraction sign and then combine like terms. As a reminder, like terms have the same exponent, and those exponents never change when you're combining like terms.
Make note that anytime you see the word than or from, you'll have to switch the order of your terms in your problem.
So let's go ahead and try example number 1. We have 4x squared plus 6x minus 9 plus 5x squared minus 7x plus 2. We have addition between them, so we will just combine like terms following the steps of addition. Combining like terms, I go ahead and highlight my like terms in different colors. 4x squared will match up with a positive 5x squared because they have the same variable and exponent. When I combine their coefficients of 4 and 5, I get 9x squared. Then I'll choose a different color for the next like term of 6x. That blue 6x will match up and combine with the negative 7x. When I combine those like terms, I get negative 1x. Then, again, for my last term, I'll choose a different color here, negative 9 plus 2. Well, that right away is going to combine to negative 7. So you can only combine like terms, which are variables that are the same, and the exponents are the same on them. Let's go ahead and try number 2. We have 9x cubed minus 4x squared plus 2x minus 6 plus, so it's addition of the second polynomial, 4x cubed minus 3x plus 1. So we will just be combining like terms, no distribution of the negative sign needed. We go ahead and start with our color coding here of 9x cubed, going with the sign in front of the 4, which is positive 4x cubed. 9 plus 4 comes out to 3x cubes. Because it's basically, when I'm combining these, saying how many x cubes do I have total when I have 9 in the first parentheses and 4 more x cubes in the second parentheses. We have our next term of negative 4x squared. There's no other term that's like it, so I can't combine it with anything, so I just bring it down. Then we go ahead and highlight 2x, that's positive, and it will combine with negative 3x. So 2 minus 3x gives me negative 1x. And then last term here, I'll choose my next color, purple, where I'll have negative 6 plus 1, and negative 6 plus 1 is going to be negative 5. Let's go ahead and try a subtraction example. Example 3 is 6x cubed plus 2x squared minus 5x plus 9 subtracted by the whole polynomial of 10x cubed minus 5x squared plus 3x minus 8. Because I'm subtracting the whole polynomial, this is subtraction, I have to go ahead and distribute here. So I go ahead and distribute to every single term because, like I said, I am subtracting this whole term. So I keep the first term of 6x cubed plus 2x squared minus 5x plus 9. And my second term changes to negative 10x cubed plus 5x squared minus 3x plus 8. From here, I go ahead to color coding everything. 6x cubed will match up with negative 10x cubed. When I combine those two terms, 6 minus 10 gets me negative 4, and I keep the base and exponent the same when adding and subtracting. Then my next term, I have a 2x squared. That's positive, and will match up with the positive 5x squared. Always take the signs in front of your terms. 2 plus 5 makes 7x squared. Next term, I have negative 5x minus 8x. When I combine negative 5 minus 3, that will make 8. Hard to give away the answer there, but that will make a negative 8x. Then last but not least, I have a 9 that's positive and an 8 that's positive. I go ahead and combine those. 9 plus 8 is 17. Let's try the next example, number 4. I have negative 4x cubed plus 9x squared minus 8 subtracted by the whole polynomial. So since it's subtraction, I know I'll need to distribute that negative to the 5x squared, the 7x, and the negative 3. Just write your first polynomial, first parentheses down where you had no subtraction to it. And then we go ahead and change the signs of everything in that second parentheses that followed after the subtraction symbol. So it'll be negative 5x squared minus 7x plus 3. Then combine your like terms. We have negative 4x cubed. There's no other x cubed term, so I just bring it down. Then we go ahead and see if I combine anything with the 9x squared, which indeed I do with the negative 5x squared. Remember, take the sign in front of your term. 9 minus 5 is going to be positive 4 with an x squared. Then we have negative 7x, which is going to combine with nothing, so we just go ahead and bring it down. And last but not least, we have negative 8 plus 3. Well, negative 8 plus 3 is a negative 5. When we have more than one parentheses, it's okay. We go ahead and still distribute when we have any subtraction. Know that you'll always distribute with subtraction. And with addition, we can just drop those parentheses. So 2x squared plus 3y squared minus z squared. Second parentheses changes to a negative x squared plus y squared plus z squared. And like I said, the last parentheses, because addition, we just drop the parentheses and have 4x squared minus 3y squared. The inside stays unchanged when it's addition, not subtraction. From here, we combine our like terms. We have 2x squared minus 1x squared plus 4x squared. When I combine all of those together, that's going to be 2 minus 1, which is 1, plus 4, which is 5x squared. Then let's do the math on our y squared terms. I have 3y squareds. Then I add one more y squared. And then I subtract 3y squared. So 3 plus 1 is 4y squared. And subtract 3, you get 1y squared. Then last term we have here are the z squareds. We have negative z squared plus z squared. Remember, when there's no number in front of those, it's saying negative 1z squared plus 1z squared, which we know negative 1 plus 1 is 0. And when I have a 0z squared term, that just cancels itself out, because 0 times anything is just 0. So my final answer here will be 5x squared plus 1y squared. Last example, we have all addition here. So I can go ahead and just drop my parentheses and combine like terms, no distribution of the negative sign needed. I go ahead and highlight my like terms. Negative 5a cubed b to the fourth power. So I'm looking for my a to have an exponent of 3 and my b term to have an exponent of 4. Well, that happens with this negative 5a cubed b4, as well as the last term of 8a3b4 as my powers there. We go ahead and combine those. Negative 5 minus 5 plus 8. You're combining them all together to make negative 2 of those a cubed b to the fourth terms. From here, we go ahead and combine our like term of 9a with negative 8a. Take the sign in front of that 8 to make it negative. 9 minus 8 is a positive 1a term. Then we go ahead and have our positive a squared b squared term combines with nothing else, so we just go ahead and bring it down. There is no other like term where your a has an exponent of 2, and so does your b. And then we have one more term, which is negative 8a to the fourth, b to the second power. We also again have nothing to combine that with, so we go ahead and bring it down. It's negative 8, a to the fourth power, b to the second here. And that's our final answer. Everything we combine, because we can only combine like terms that have the same variable and exponent on them. Now we are going to go ahead and divide polynomials. What we do is split the polynomial that is in the top numerator by putting each term in that top numerator over the denominator terms every single time for every single term. Then we simplify each term. The major steps of simplifying, what you want to remember, is that you divide the numbers and you will now subtract the exponents. So if you really remember that and keep saying that to yourself, divide the numbers, subtract the exponents. Let's go ahead and try number 1. So the first step is I'm going to take all three terms in the numerator, my 3x cubed, then my 7x squared, and then my negative x, and put them all over my bottom term of x. Split it up so then I can divide the numbers. 3 divided by 1 is 3, and subtract my exponents. I have 3 in the numerator minus 1, my hidden ninja 1 exponent in the denominator. Next term, again, 7 divided by 1, divide the numbers to get you 7. Subtract the exponents, which will be 2 minus that hidden ninja 1. Again, last term, we divide the numbers. Negative 1 divided by a positive 1 is a negative 1. And then we subtract the exponent. Since there's no exponent there, it's that hidden ninja 1, so it's 1 minus 1. Final terms are going to be 3x squared plus 7x minus 1. What happens to my x minus 1 is it becomes x to the 0 power, and we know the 0 power rule states that any exponent that is a 0 power on that attached base is going to make it 1. And we know 1 times negative 1 is a negative 1. Let's go ahead and try example number 2 again. First step is line up my first term of 80x cubed all over 8x. Then I'm subtracting that 40x squared yz all over 8x. And then I have a positive 8x all over 8x. As a reminder, when there's no exponents written, it's an exponent of 1. So I'm going to put the hidden ninja 1 on every single base that doesn't have an exponent specifically there because we know it's that hidden ninja 1. One fraction at a time. The first fraction, 80 divided by 8, is going to be 10. Divide the numbers, subtract the exponents of 3 minus 1. Second fraction, again, divide our numbers. Negative 40 over 8, that's negative 40 divided by 8, which is negative 5. And I subtract the exponents. Now, only subtract the exponents on like bases, so on my x terms. Y has nothing to be combined with, and neither does z. I'm not subtracting the exponents there because there's no y or z terms in my denominator to subtract from. Then, last term, divide the numbers. 8 divided by 8 is indeed 1, and I subtract the exponents of x, 1 minus 1. Final terms are going to be 10x squared minus 5 with xyz, and then I add 1. As a reminder, what happens to this x1 minus 1 is it becomes x to the 0 power. We know any base raised to the 0 power is just 1. 1 times 1 is itself 1 there. And that's our final answer.
So again, for example number 3, we want to break up the problem into every term being divided by the denominator. So the 5y to the fourth power will be divided by 5y. 10y squared will be divided by 5y. And so will the negative 50y be divided by the 5y. As a reminder, we're going to go ahead and actually divide the numbers. So 5 divided by 5 is where I get 1. And don't forget, we subtract the exponents. I have a 4 of exponents in the numerator, and in the denominator, don't forget that the y would be to the power of 1. Again, I divide my next numbers. 10 divided by 5 is a positive 2. I subtract the exponents. I have 2 minus an exponent of 1, don't forget, which will be what we do next. Last one, I divide the numbers. Negative 50 divided by 5 is negative 10. Subtract the exponents here. In the numerator, you have an exponent of 1. In the denominator, you have an exponent of 1, so we do 1 minus 1. Simplifying our exponents, we go ahead and get 1y to the third as our first term, plus 2y to the first power as our second term. And the last term is going to go ahead and just be a negative 10. Because as a reminder, when we do y to the 1 minus 1 power, that's just y to the 0, which we know is 1. And anything you multiply to negative 10 times 1 there, or 1 times any number, is just itself there. So cleaning this up, because again, you might not see the 1 written on the y to the third power, but it's not wrong if you put it. And same thing, you might not see the 1 as an exponent on y, but it's still not wrong if it's not there. Last example, number 4. Again, I take every single term in my numerator and divide it by 8 to the x here. And then I go ahead and actually do that division. For my first division, remember you divide the numbers, so 80 divided by 8 is 10. And we subtract the exponents. Don't forget to put an exponent of 1 in the denominator. That way we're doing 3 minus 1. We go ahead and divide the numbers of, take it, a negative 40 divided by a positive 8, that's negative 5. And we subtract the exponents that are alike here. The only terms that are alike are the 2 and the 1 on the same letter x. What happens with the letters we have left is we just write them. They had nothing to divide by, so they just stay the same. For the last term, we're dividing by the 8x by 8x. 8 divided by 8 is 1. And we subtract the exponents here. X to the first power minus another x to the first power, so it's x minus 1. We go ahead and actually subtract those exponents to simplify this down to 10x squared is our first term. Second term is a negative 5x to the first power, because that's what we get when we do 2 minus 1. Y and z is just written next to it. And for the last term, as a reminder, when we have 1 minus 1, that's 0. X to the 0 power will just come out to be 1 here. When you multiply 1 times 1, you just get the 1 as your last term. Cleaning this up, it's 10x squared minus 5xyz. Again, it's okay if you put exponents of 1 on any of the xyz. It's not wrong. You just won't see it in a multiple choice. And then plus 1 is the last term. We want to make 2 reminders here. Anything to the 0 power comes out to be 1, so don't forget that. Basically, it's saying you have 0 of those letter B's left in this example. And don't forget that the quotient is going to mean to divide. That way, when we use Desmos for the next problem to find the quotient means to divide. The first term of 7a to the fourth power plus 35a cubed minus 14a squared all over the 7a. That's what the quotient means. You put the first part in the numerator, and the term after the and is what you're dividing by in your denominator here. When I put that in Desmos, I go ahead and get C. Go ahead and try it yourself.